Thank you. First of all, I agree completely. I'm sorry, I usually try whenever I go to speak to some place to craft at least some words on the local language. But given my inability to go beyond the one phrase, I decided to skip that part for this time. I'll try next, I promise. All right, so first of all, I'm really, really impressed to have so many people here today. At the meetups we do in Madrid, it's of course a smaller city. We don't have so many people. So I'm really glad to be here, and thank you very much for bringing me here and for you to come to listen for me for 1 hour and a half. That's brave. So some known faces here, some friends around. That's cool. Let's get it started because that's what you're here for, I guess. So before we start, I'm going to talk about Java, of course, but also Postgres, the relational database. I'm sure you know about it. How many of you use Postgres? Really? I'm sorry, I need to take another picture of that. Can you raise your hands again? That's really cool. Do you know there's a Postgres conference happening right now in St. Petersburg? No? Okay, so I came here also because of PG Day Russia, which is happening now in St. Petersburg. Yesterday was the VIP day, today has been the tutorials day, and talks start tomorrow and the day after. So I'm pretty sure you still have the opportunity to join the conference. I'm not involved with them per se, but they're good friends too, and they brought me here. So if you're interested into Postgres, I would definitely recommend you to go there. I'm still pretty sure there's some places registration open. So just go to pgj.ru. By the way, it has a really cool website. Looks like a comic. It's very cool. All right. So a lot of you use Postgres. That's very cool. And then I guess you also use Java. So that's perfect audience then. Let's talk a little bit about this. What I want to focus is on some aspects that are usually not very well known in terms of Postgres and Java. A lot of some assumptions that I want to probably try to prove whether they are correct or not, especially in terms of performance. So there's also some features that I want to talk about. This is just a very brief part, but Postgres, one of the things that I like the most about Postgres is the huge array of features of functionality that it provides to you as a user. And not all of them are accessible from Java. And that's a shame for me. So I want to also talk about that and show some possible ways of fixing that. It's not easy, but I hope you're also familiar with open source here. And you maybe want to join the effort and submit some pull requests. All right, so let's get started. First of all, a little bit about myself and more specifically the company I work for. It's called 8K Data. I'll buy you a beer for the first one who guess what's the meaning of this name. I left the question open for the break. But I promise I'll buy you a beer for the first, or a vodka, for the first one who guesses what's the meaning of the name of my company, 8K Data. We focus on research and development in the database space. So this means we came up with stupid ideas and then we work on them in databases, right? But we are also, our background is to be Java developers. So we develop in Java, we form part of a group, very nice group called Java Specialist. We go to the JCrete conference, which is the hottest Java conference in the world. Literally, that's because it takes place in Crete in the summer, so it's very hot. And we are also very involved with the Postgres community, of course. We founded the Postgres Spain user group, which is the 5th largest user group Postgres user group in the world, with over 700 members, which is a pretty large number for us. So this is all about me. It's easy to find me on Twitter, LinkedIn. If you have any question, if you want to say something, just shout. All right, so let's get started with Postgres and Java, these two icons. It's difficult. So first things first. I don't need to brag here about Java, that's for sure. But I want to make a point important, and it's that Java is the enterprise language by default, right? You all know this. Most enterprises use Java, but also a lot of startups use Java now. So it's one of the probably most used languages in the world, and I'm going to talk about that. And so it's very important. I want to raise the importance of Java in the world of Postgres, which is, by the way, one of the things that I've been working on hard throughout the last years within the Postgres community to raise awareness of the importance of Java. Indeed, just because of this reason, most of the code that accesses a Postgres database is coming from Java. This is very strange, because if you think about it, Postgres, it's almost C world. Postgres is written in C, in ANSI C, no, not even C++, so there's no object orientation, it's just pure C, like very pure. And the same way are the Postgres hackers. They are very pure C developers, which is good. But most of them don't like Java, right? They say it's very slow, that only poor souls who don't know how to manage memory use that kind of languages. You know, this is a common theme when I discuss with them, but it's funny conversations. But the point is that despite that, I want to raise this awareness that Java probably is the language that most people use to interact with Postgres. So the Postgres community needs to pay more attention to this. And of course, both are very well and mature languages. So first of all, talking about popularity, because some people say that Postgres is success from all the languages, but I try to basically analyze the market. And this is, I don't know if you can all read this, but this is one of the indexes of programming languages popularity. It's called TIOBE Index. And basically it says that Java, it's the #1, or was in February this year, the #1 language in terms of usage worldwide. It was #2 last year, but now it's come back to position #1 with a significant lead over the next most used language, which would be C. By the way, if you want to ask any question, please interrupt me anytime, no problem at all. There will be some time for questions at the end, but feel free to interrupt. There's never a stupid question to ask. And if you want to ask in Russian, feel free to do so. I'm sure someone will translate. Otherwise, I'll just answer 42. All right, so back to the TIOBE index. You know, Java is very, very popular. So it's #1, leading by a significant margin over the next language. But this is not enough to justify the importance of the Java language within the Postgres community, because that's just one index. So I took another one. Let's look at GitHub. Now GitHub is the place to be for open source and some other projects too. And by analyzing the trends in GitHub, well, Java is not the first language here because it's JavaScript. It's more cool, right? But it's growing significantly. If you look here, Java, some years ago in 2008, was the 7th most popular language in GitHub, which means that initial hipsters didn't like Java very much. But nowadays, hipsters seems to be more conservative, whatever you want to call it, and they use Java more. So now it's in 2nd position, and I bet the hipsters will finally realize that JavaScript is not the magic bullet for everything, and at some point Java will overtake this. Let's see what happens. But even if this is not enough, I took a 3rd index and find a 3rd one called PYPL. It's another index of popularity using some different metrics, some different ways of measuring popularity, and surprise, Java is again the #1 language. They don't agree on the 2nd one, but the thing is that they agree on the 1st one. So Java, according to this index, is also the most popular language in the world. So, it is very important in the world, it is very important in the enterprise world, and Postgres needs to be paying a lot of attention, I would say more than it's doing right now, to Postgres, to Java, in terms of Postgres. Okay, so far so good. Let's look at how we can interact with Postgres from Java. How would you do it? JDBC. Okay. So using a JDBC driver, right? Which one? Huh? Type 4? Did I hear? Yes? Did I hear type 4 or there are 4? Okay, so there's a JDBC driver, right? Okay. Any other option?
Hibernate.
Sorry?
Hibernate.
Hibernate. Sure, but Hibernate will end up using probably the JDBC driver itself, right? So what if I don't want to use JDBC? Below, I mean, hidden or not? Is there any other option or just JDBC? Rest? Restful. Well, there might be some options, but I bet they also use JDBC driver. Might be wrong, just correct me if I'm wrong. Any other option?
PSQL executable.
What is it? Oh, okay, PSQL executable. Yeah, that's a cool meme. I benchmarked that some time ago. So you can, from Java, you can use Process Builder and launch an external process, and that external process is PSQL, the client, Postgres client from command line. Then you capture the output and you parse it, and you're good to go. Sure, that's a good option. Cool. +1 for bringing an innovative answer. Any other one?
GNI and C.
GNI and C. That's, I don't know who was that you. Okay, +2. That's a really cool answer. Yes, that's one option. I'm gonna talk about that one. Process Builder, I also had some slides in the past, but I deleted that one because it was a little bit. But yeah, GNI and C. So there's the C driver in Postgres. So maybe we can also use that in GNI to interact with Postgres. Okay, good enough. Let's look at the options. There's even more options, but few people know about them. So first thing that I want to present you is that there's more options than the JDBC driver. So first option, the JDBC driver. It's a type 4 driver. Raise hands who of you know what it's a type 4 JDBC? Okay, so deserves some explanation. So there's, according to the JDBC standard, there's like 4 types of drivers. JDBC means, by the way, I didn't know all the types, because basically you want to use type 4. But basically, type 1, if I recall correctly, it's something that works on top of ODBC driver. So you take an ODBC driver and wrap it into JDBC API, and ta-da, you get a JDBC type 1 driver. The type 2, it's kind of a native driver wrapped with the JDBC standard on top of it. The type 3, it's kind of a middleware translation layer. So you use something else who talks to the database over the wire protocol, and then you wrap that with the JDBC calls. And type 4, it's native driver, which means that the driver speaks the protocol. Postgres has a protocol called Phoebe, front-end, back-end protocol, that's the meaning. And it's a binary protocol that exchanges the messages with the server. It's a very cool protocol, by the way. It's asynchronous. We'll talk a little bit about the protocol. And well, the Java driver implements natively this protocol. So it has Java classes, no C code, no nothing else, that write to the socket in binary form, writes bytes, reads bytes, you know, all this stuff, and talks to the Postgres database. So bear this in mind, because this is going to be important throughout this talk. Java driver is writing bytes over the socket, goes to talk to Postgres, and comes back and, you know, gets the bytes back and do the stuff. So this is type 4 driver, native implementation of the wire protocol. It is an official driver. There's no officiality in Postgres, but it's the, I would say, 99 point a lot people use this driver. And honestly speaking, the driver development process was a little bit stalled a couple of years ago. The traffic on the mailing list dropped to almost an average of 1.x messages per day, which is a very low number. But around 2 years ago, there were some people who joined back the community, and they were very active, and now it's very active again. One of the first things that they did is to put the project build management under Maven. Thanks God, it was on before. I don't know, maybe it could be better, but definitely that's something. And it has a lot of now power. There's still a lot of help required. So if you like this, if you like databases, if you like Postgres, there's many things to do on the Postgres driver, so feel free to join. Now, the good thing is that they also tackled performance significantly, and the latest versions of the driver perform significantly better than prior versions. So if you're using Postgres, and most of you are, and you're using the JDBC driver, which I guess most, or if not all of you are doing too, check your driver version, because the latest ones are significantly faster than previous versions. Okay, it's a good choice, so I have nothing against the JDBC driver, of course not, and I know the developers, I know they're good friends too, so it's a really good option, it's a solid option, so just go for it. Now, it's not the only JDBC driver available in Postgres. How many of you knew this driver called the next generation, PGJDBC next generation driver? One hand. Okay. So it's a second driver. It's a JDBC driver, so it has the same API. So exchanging one driver for the other should be just one line of code. Well, if you're using Maven, like 3 or 4, 5 indeed. But whatever, it's very simple. Should work as is. The idea about this driver, it's different from the original driver. The original driver, first of all, has some goals related to backwards compatibility. It goes back to 7.4, Postgres 7.4, which is definitely no longer maintained. And some other, supports the older version of the protocol. I think it can go even back than 7.4, maybe 7.2, 7.1. It has also the idea of trying not to use any external dependency, which is something debatable, but has its reasons. And so it has like a lot of backwards compatibility. The code is well, it's not exactly easy to cross because there's like many layers of abstractions to try to represent all the versions and all the protocols and all those specific cases. And as I said, tries to avoid external dependencies. This idea of the next generation driver was completely different. They basically said, let's start from scratch so we can have a small maintainable code base. Let's try to use as many dependencies as possible to write the less code, the better. And we're not even gonna care about people using Java 6 or less than that. Screw them. And so it requires Java 7. And in my opinion, one of the main advances of this new driver is that they use Netty for the I/O, network I/O. Do you know Netty, the I/O framework, network I/O framework? Just to be curious, how many of you do know or use Netty? Okay, that's a little bit less than half, I would say. I think it's one of the best frameworks available in Java, period. It's amazing, and it's really, really fast. Asynchronous, event-driven network I/O framework. So this driver chose to use Netty as a framework, as a building block for all the I/O. Remember, it is a type 4 driver, and type 4 driver speaks natively the protocol, so you need a way of speaking TCP/IP over sockets with the Postgres protocol. And with Netty, it is very simple to implement the Postgres protocol on top of it. Also did that myself, so I know the stuff. And it's doable, and it's very cool. So this is one of the advantages of this driver, that it uses Netty for async I/O framework for I/O. It was meant to be really fast. That was also one of the main goals of this driver, to be faster than the original official JDBC driver. And the only drawback that I see about this driver is that development seems to be almost stalled by now. The latest version available is 0.6, and it was released in October last year. And there has been no versions since. I'm not following like every day. There might be some activity going on, Haven't checked lately. But still, I mean, code is there, it's on GitHub, it's open source. So, you know, you can take it, you can fork it. It's all yours. One of the things that I wanted to show here is to compare both drivers. And so we took some benchmark that Joel Conway from the Postgres community did to compare them and rerun it, comparing this JDBC driver and the Postgres, the next generation driver. And the results are basically very conclusive. There were like 6 different tests in this benchmark, and all of them showed that the official driver is now faster than the next generation driver. This is mainly because the official driver had a lot of performance improvements, as I mentioned before. So remember, update your dependencies and test your software with the newest versions of the driver, because they are significantly faster. Some time ago, this graph was reversed. The next generation driver was significantly faster, at least on their certain scenarios, than the official driver. This, by the way, this is execution time, so less is better. One of the other drawbacks I forgot to mention about the next generation driver is that it doesn't support the copy protocol. The copy protocol is one of the sub-protocols under the Postgres wire protocol that allows very fast data ingestion on or taking from Postgres. So that's also an important limitation because many people depend on the copy protocol for really efficient I/O. That was a question?
What was the benchmark?
So this benchmark is a benchmark did by one of the community members, Postgres community members, called Joel Conway. And it is a software he was meant to publish to GitHub when he got approval from their company. But I think he hasn't done that yet. We got a copy from him and ran the benchmark ourselves. But I believe it's not public yet. But it was a simple benchmark. The idea was that all the possible combinations for running the benchmark were computed via cross joins by SQL queries, and then the tests were run. But it was basically like some queries involving some of the tests involving connection to the database, some others without, some with copy, some with direct inserts or selects. So this represents 6 different test scenarios. What else? Surprise, there's more JDBC drivers. Who knows another JDBC driver for Postgres? Yeah, okay. There's another driver for Postgres by a company called Progress. Yeah. And do you know a company called Progress? Yeah, okay. Some people here. So it's fun because I thought this company was like unknown and like a tiny company. And last year they acquired another company for 300 million. So I bet they're not a tiny company, we thought. Surprisingly, they have a driver, a JDBC driver for Postgres and for many other databases too. And it's not open source, so this is commercial software. What is interesting, and I've been talking to them and trying to find out, they say that this is a type 5 JDBC driver. So if you go to Wikipedia or whatever source of information you want to go to and look for a type 5, you'll find nothing.
Is it just a marketing bullshit or what?
Well, you said that, I didn't. Supposedly a type 5, if you read their product data sheet, they talk about you know, some extra features that, well, I mean, has some, I'm not saying it's a bad driver, not at all. I think it's really cool. It's just that I didn't get exactly what is a type 5 driver, but it has a lot of features that some of them are not present on the open source drivers. They're mostly related to query management and to linking to other data sources and so on. I haven't tested it myself. Would be cool, but haven't done it. But it's still another option, and there's I bet they have many customers who use this kind of drivers. I don't know if for Postgres or the other databases, because they have, as I said, JDBC and ODBC drivers for many databases. But there it is, so it's still another option. There's also non-JDBC drivers. So there's one driver called the Postgres async driver. Have you heard of it before? Postgres async driver? Okay, so this is a database driver. It's non-JDBC, so you cannot swap in, swap out the driver in a code that uses current JDBC driver. But it's cool because it's mostly asynchronous. And this is very surprising. And this is one of my main concerns about JDBC. The JDBC spec was written a long time ago. And by the time it was written, there was not that much hipsterism about asynchronous operations, as it is nowadays, right? So JDBC is synchronous. However, the Postgres wire protocol, the Phoebe protocol, is mostly asynchronous. I would say it's completely asynchronous. Indeed, it has some messages, which is basically a sync message to try to get to sync, to put some barrier, which means everything is asynchronous. So a JDBC API on top of the Postgres protocol is probably not the best fit, because you're losing all the asynchronous capabilities that the protocol has. So this driver built an API, which is its own API, which is nor good nor bad. It's just an asynchronous API. And it also implemented the wire protocol to talk to the database, of course. Surprisingly, it also uses Netty. So it's a cool driver. It's written in Scala, and it's also available for MySQL. So it's not Postgres specific per se. It has like a MySQL and a Postgres variant. It's very active, so you might want to check it out. I think it's pretty cool. I'm not finished. There's even one more. There's another JDBC driver, which is built on top of RxJava. How many of you use or know about RxJava here? Okay, so RxJava, which I love it, it's a framework for basically doing reactive operations in Java. By reactive, if you have read the reactive manifesto and so on, it basically means that it's a very easy and convenient way to compose asynchronous operations. So asynchronous operations are very cool. Everybody loves them, right? But then you start nesting callbacks and callbacks and callbacks and callbacks within the callbacks and so on, and the code gets very messy. Looks almost like JavaScript. Sorry for that. So with this kind of reactive frameworks, they basically allow you to compose operations. So you basically set up a chain of operations, and then they will be lazily performed. And so you basically, one operation runs on the result of the other one. All those features are more or less behind the scenes, and you can specify like very powerful patterns in terms of the operations that you want to accomplish. So that's RxJava, one of the frameworks for reactive programming in Java. And built on top of this framework is this Postgres driver. It is surprisingly JDBC, and but it performs JDBC in such a way that it turns JDBC into asynchronous calls, which is pretty cool. So the other characteristic of this driver is that it's not Postgres specific. It resorts to the JDBC driver of your choice. So you can talk to any JDBC database, but it uses JDBC behind the scenes.
So it's like a wrapper.
Yeah, it's kind of a wrapper. Okay, so this is about drivers. So I hope that at least at the end of this talk, at least you learned something today. Just new options, new drivers for Postgres. Now let's think about even more. Let's think about non-driver options for Postgres. Because all that we want at the end of the day is to interact with the Postgres database, right? Whether it's a driver or something else, we may look at that options. So apart from the calling the PostgreSQL through Process Builder or something like that, which I have not documented on these slides, there are other ways. And the first one was already pointed here. Why, if we take the libpq, which is the C implementation of the Postgres protocol, which is a library in C, and use GNI to call those C methods from Java? That's viable. So someone did this and took a library called Swig, which basically helps you take a C library and run all the GNI stub code and generate Java APIs for calling those C methods. It's a very simple thing to do. You can do it at home. Just click on these two links over there. And the other one is a blog post that explains how to do it. But just basically run Swig and over the PQ library, and it will generate Java code to call those via GNI. This is very cool. It looks like it's a little bit overkill, maybe a little bit stupid, but has one very significant advantage. And that advantage is that you'll be able to access all the features, all the capabilities that Postgres exposes via the protocol from Java, which is not true from the drivers. I'll talk about that at the end of the talk, after the break, because I know there is a break in the middle. You don't have to be like 90 minutes in a row listening to me. But there are some features that are not available in the drivers, in any of the drivers that I mentioned before. So if you want to talk to them, you may use this option. Indeed, Enterprise DB, which is one of the main companies behind Postgres worldwide, they have a replication software that replicates like from many databases to many databases. And the way they replicate from Postgres is using one of the most cool features now available in Postgres called logical decoding. And I'll talk about later a little bit. And logical decoding is not available in any of the drivers. So if you want to use logical decoding with Postgres, you don't have options with the current drivers. So you may use a technique like this, which is use GNI over the libpq library. It's also useful for Unix domain sockets. Postgres supports also connections via Unix domain sockets rather than TCP over IP and Ethernet or whatever. You know what's Unix domain sockets? Are you familiar with it? Yeah. Okay. Yes, didn't hear so many people. So basically Unix domain sockets is a way of doing socket communications on local host over a simulated socket, which is a file in the Unix sense. And it's of course much more efficient than running over Ethernet and TCP. So it's faster, significantly faster under many scenarios to communicate over Unix domain sockets. And Postgres supports Unix domain sockets. If you're talking with a Postgres database in local to your client and you're using PSQL, Postgres client, you can use Unix domain sockets and it's more efficient. Also the C driver supports Unix domain sockets, but the Java driver doesn't. It's not far from there, by the way, because there's support for some abstractions which will help it to achieve Unix domain socket support, but it's not supported yet. You may also submit a pull request, because it can be done in Java, no problem. So if you're communicating in localhost Unix domain sockets, very cool. And again, using this technique, JNI over the libpq library, you could use Unix domain sockets too. But there's more. In Postgres, good news is that you can also do server-side Java. How many of you have heard of PL Java? All right, 2. So PL, procedural language, that's the name that the languages support in the database have in Postgres. So there's Postgres, the mainstream language, which is PL PGSQL. There's a question over there?
Yeah, is it natively support for PL/Java, or is it kind of external model?
Okay, so it is external to Postgres. It doesn't come with the default distribution of Postgres.
So I'll have to install the module for corporate use?
Yes, yes. You have to install it separately from Postgres.
Not distributed natively?
No, it's not. You basically have to download it from GitHub and then install it. However, the point is that it was distributed. Okay, let me tell a little bit about the story about PL Java. PL Java is a very old project. It started like maybe 10 years ago or so. And by that time, it was based on old Java. So it was Java 1.4. At some point, it even used GCJ, GCJ, the GNU GCC compiler for Java that compiled to native code. So, well, that was a version of the GNU compiler which could compile Java code to native code. The idea was cool, but we prefer a JVM, right? So it was abandoned, whereas PL Java at some point used this functionality. So it is packed. I mean, if you use a typical, like for example, Linux distribution, you will find that there's PL Java packaged for it, but I'm sure it's going to be an older version, like one of these 1.4 Java-based versions, and I definitely don't recommend that. There's a new version, so this happened like a little bit like the same that happened with the JDBC driver. That development was a little bit stalled in the last years. Same happened to PL Java. But PL Java was even worse. It was like almost abandoned like 6 years ago. There was zero development until 1 year ago, where some people came back to PL Java, took it from there and started improving. And they released like version 1.5, which was the first version in like 8 or 10 years. And it was released this year, like some months ago. And that version is the version that you definitely want. So this version, I don't know if it's yet packaged by the distributions, and it's not by default on Postgres. It's not part of the Postgres distribution. So it's not considered the core, Postgres core. Now, the cool thing about this is that Postgres, it's very pluggable. Postgres supports augmenting the Postgres functionality in so many ways, and some of them are the ability to plug in new languages. It's called in Postgres procedural languages, which is basically a way of running server-side code. And this is very cool because you can run code that can, for instance, like filter data that you don't need to ship it to your application to filter there. So you can really improve performance by running some server-side code. It's not that I'm advocating right now to ship all your business logic to the database. I'm just saying that before shipping 1 million rows and then filtering them to get 3, maybe you could filter them server-side if the computations are not very complex. By the way, PL Java, which is one of these procedural languages, which basically allows you to run the server-side code in Java, because in Postgres there are so many languages that are available for the database. You can write server-side code in PL/PG/SQL, which is the default language in Postgres, which looks a little bit like the Oracle's PL/SQL, and it's very simple to use. It's very cool. No. I know there are some differences. You can also use Python, you can also use Perl, if you want to. You can use Bash, you can use R, you can use TCL/TK. So there's like many languages available for as procedural languages, and Java is one of them with PL Java. The way PL Java works is that whenever you call a method or function in PL Java in a part of a user session, it basically instantiates the JVM, loads your Java code, and runs your Java function. So this technique, it's good enough if you want to perform like long operations, and it's been used a lot to do XML processing inside the database, because Java is very good for doing XML processing. Nowadays this is not hipster anymore, but still there's many people doing Java XML with Java because of the amount of libraries available for Java. So this is a really good one technique and used for PL Java. The good thing about PL Java too is that firing a JVM, we all know it's not cheap precisely. Around nowadays in my laptop, which is a really good one, I would say, it's like 0.5 seconds per 0.4 seconds. There's of course other JVMs that are faster to start up. But anyway, it's not non-zero cost, right? And the good thing about PL Java is it's tied to the user session, right? So when you close your connection to the database, next time you call a Java method, you'll need to fire the JVM again. The cool thing is that it maintains the JVM live throughout the execution of your connection, your user session. So if you need to call like many times Java code, those calls will be definitely cheaper because the cost of firing the JVM will be used only once. All right, so
it's like RMI, like sort of remote method execution?
It's like a function. Like if you want to call a function, a scalar or non-scalar function in SQL, you can write the code of that function in Java. So you'll do a SQL query, which could be select function call, and that will run your Java code inside the database. Or if you use a set returning function, which is a function which returns a result set, You can say select star from function name, and that function name, it's a Java code that can do whatever you want as long as it returns a table. So it's very powerful for this kind of things. But we'll see some limitations. Phoebe. So Phoebe, it's a work in progress, let's be honest. More than work in progress is a project that started some time ago and stopped development, but it's very cool. Well, I shouldn't be saying that because I started that project. But the ideas I think are very interesting, and that's why I wanted to expose them here. Unfortunately, our company roadmap asked us to shift priorities to other projects, and we stopped development, but we'll take it some time. It started, by the way, in this hottest Java conference in Crete. Development started there. The idea of Phoebe is to create a new Postgres driver. Hey, there's many already, right? So why do we want to do this? Well, we wanted to follow some patterns that we felt they were right to do with Postgres, to interact with Postgres from Java. First things it does is that it has to be async and reactive by default. Async, there are a couple of options already that I presented you to them. Reactive is even more important for me because reactive, it's also a pattern of reacting to events, to something that happens on the database. And if you really think about a query, when you do a query and you start receiving results, the very act of receiving a result from the database, it's an event, it's reacting to an event. And that is, according to the Postgres protocol, an async operation. So it would be really cool to have your rows to react on those as soon as they come to you. And there's many other operations that can be also reactive. Like, for instance, the connection to the database itself. You can connect asynchronously to the database and then it will say, hey, whenever this connection is fired, then I want to react on it, and then I want to fire this query, and then when the results come, I want to react on them and do whatever I want. I want to subscribe to these streams of rows. So this is what we wanted to accomplish with Phoebe, and that's why we started this project. We also want to focus on what is now the reality. The reality is that most of the time, you won't have a single PostgreSQL node. Because sometimes you want 2 or 3 or 5 or whatever number, because you want a cluster, because you use replication and you have a master node and a secondary node or many secondary nodes, and you can perform read-write operations to the master node and read-only operations to the secondary nodes, right? So this notion of a cluster of servers, it's not present in any of the drivers available as of today. The JDBC driver has this tiny notion about jumping from one server to another if one fails. But other than that, there's no ability to say, hey, I want to run this query, which is a read-only query, on the first secondary node available. Or given that this is a read-write query, it has to go to the master node. This is not built into the drivers, and we wanted to build this into the drivers because we believe that Postgres is no longer a single node database. And most importantly, we also wanted to use Netty as an network I/O framework for developing the protocol part, which makes it very easy and very performant and very asynchronous. But even more important, we realized one of the problems in terms of performance, and we're going to see that today, is that there's a lot of overhead in bringing data to Java from Postgres. Shouldn't have said that. Revealing some part of the story later. Anyway, there's even worse than that. There's a lot of copying. There's a lot of object creation. And we don't like object creation, right? Then it calls a garbage collection, and we don't like garbage either. And if you really analyze the performance, and we have had to analyze the performance of the database from Java very significantly, I'll tell you later why, then we realized that there's a lot of copying, and we wanted to avoid this so many copies of data that happen on your JVM. And Netty, it's able to work on off-heap memory, on memory that you have to manage yourself, but it's off-heap and can achieve 0 copy from the network interface to the JVM, or at least 1 copy, but not many copies. So one of the goals of this driver was also to use Netty, which has these subcomponents, these libraries, to manage off-heap memory, and have byte buffers. They're called byte buffs, but anyway, look, they're like byte buffers, Java byte buffers, to keep them in memory off heap. And rather than copying that to heap memory and then start creating objects, to maintain them there and provide all the methods, all the accessors as views that target internally these off-heap memory buffers. So you would avoid a lot of object creation and garbage collection. It's not easy, but it's one of the goals. So we also wanted to add many features on top of it, like the binary mode. The Postgres protocol supports a text mode and a binary mode. In text mode, everything is sent as text. In binary mode, data is sent as binary. It is, of course, more efficient most of the times to send data as in binary mode. You can do it even on a per column basis. The protocol is very flexible. But some of the data types in Postgres are not sending data in binary format. We want to support binary format for everything. So you can choose at least, right? Also support Unix domain sockets, which, by the way, by using net is very simple, very easy. To support logical decoding. Logical decoding, it's this functionality of Postgres that was introduced very recently that allows you to capture every change that happens on Postgres as a logical delta. So you say you insert a document or a row, and you get via the logical decoding interface another data that says this row was inserted. If there's an update, it tells you this row was updated, the old value was this, the new value is that. And that is presented with an API that you can also talk to, so you can get all the deltas that happen to a Postgres database. Every change that happens to the database, you'll get that as a delta, as a div, let's say, from the logical decoding functionality of Postgres. And this goes over the replication protocol of Postgres, which is not built into the drivers, because it's used for replication. And JDBC does not talk anything about replication. So in order to access logical decoding from Postgres, you need to do something else. And so we want to build this into the driver. There's also the possibility of doing query pipelining. JDBC and none of the drivers that I mentioned, probably except with the async driver, can do query pipelining. Query pipelining means I want to fire these 5 queries, and they will be executed in order by Postgres, but I want to get the results as soon as they come back. And only if there's an error in the middle, I'll have to roll back all that stuff or manage the errors. But I don't want to fire the first query, wait for the results, then fire the next one, then wait for the results, and so on, because it's, of course, much less efficient. And this is possible to do with the Postgres protocol. It's not extremely easy. Probably a next version of the protocol will include more functionality to be able to pipeline queries, but it's doable. You can pipeline queries as of today. And so we want to also build this into the driver. And in general terms, we want to use fully asynchronous operation, a fluent style API, and compatibility down to Java 6, something that we will probably drop soon anyway. And this is a little bit how the API looks like. I don't know if you're going to be able to read from right there, but the idea is that it should be very easy to compose operations, because this is reactive Java, right? So it's also based on RxJava. So the idea is you can instantiate a client, a Postgres client, and then you say create, this creates a client, and then you say TCP/IP, and then the address of one server, and then you can say also TCP/IP and the address of another server, and this means I'm going to work with 2 servers at once. And then I say all hosts, which basically means connect to every host. If I would say just one host, it will connect to the first one, and then drop the connections to the other ones that you have fired asynchronously. And then whenever you react to these connections, you call init, that fires the connections. And now you can subscribe to events that happen on this client. Then you take the client, say on connected to observable, and subscribe. The observable is a reactive interface. So the client will react on the event of getting a connection, and then you can subscribe to that event and do whatever you like with it. As I said, there's not much in this project done yet, a lot of desires, but if you would be interested in it, just let me know, because there's a lot to do and there's some code there, but it's not even usable as of today. Sorry. Okay, now let's dive deeper. So let's look at measuring the performance. How are we doing with time?
I think it's a good time to get a break.
Okay. All right. So, how it was interesting the time before. There's been many questions in the break. I won't be able to repeat them here, but at least I just want to briefly mention. Sorry for the self-plug, but I want to mention one project that we are working on. Some people were asking me. And it's an open source database that we are building right now. It's called ToroDB. Toro means bull in Spanish, and so it's like the bull DB, right? Because I'm from Spain and we like bulls, so it's very understandable that it comes from Spain. That was our goal. So ToroDB, it's an open source database, which it's both a NoSQL and SQL database in the same place. So it is NoSQL because it speaks the Mongo protocol, MongoDB. So you can take the MongoDB drivers, MongoDB software, and talk to it as if it were Mongo. However, it's also a SQL database because data ingested via the Mongo protocol gets analyzed and transformed into a relational form and gets stored into Postgres as a set of relational tables, purely relational. You will infer even the relations of your data, so you can do your queries on SQL. So you can do queries with SQL, you can do queries with the MongoDB API. It also replicates from MongoDB, so if you have a MongoDB cluster, it can work as a secondary node. You will replicate live all the data from MongoDB, and then you'll have all your data on a SQL node. So you can do SQL queries, you can connect to the BI tools that talk SQL, speak SQL. You can use it for migrations. You can use it for everything. And this is written in Java, and it's a GitHub. So feel free to check it out if you like it, ToroDB. All right, back to our topic. So now let's look at performance. So I've explained to you that there's many options to connect Postgres with Java, right? To use the many drivers available, the many options that are available. And now I want to look at performance. I'm going to focus on the main option, the option that use most of the people, which is the official JDBC driver. I want to look at the performance, but I'm going to look at the performance from the perspective of the end user. I want to understand what is the cost that we are paying for using this driver. And there's many things into it. So let's start. The first thing, I wanted to work with a very simple example. So I want to analyze the performance of doing queries. Simple stuff, right? After all, if you use a database, most of the time we're doing queries. So I want to look at the queries. So I created a very simple table that contains just 3 columns: I, integer, T, text, and J, JSON, because we're all hipsters here, right? And we love JSON. So this very simple example, I generated random data. Well, it wasn't that random. But I inserted 10 million records in this table. And data looks like this. So I, number, T, hello there, number. If a weird tilde there, that's a typo. That's not even Spanish. I mean, it's in Spanish tilde, but not in the right place. And then a JSON document, which is basically the same data that is contained on the other 2 columns. It doesn't really matter, it's just a number, a text, and a JSON field. And we have 10 million records here, and we're going to query this table in several ways. So let's look at the very simple example where we're just going to do a select star from this table. It's called number, and I'm going to read the data. So I want to measure the performance of this query from Java. Now, how do we measure this performance? Well, of course, we can write our own software to do many runs, because of course we know that the JVM is going to create a lot of optimizations for our code. It's going to cheat us badly, so we need to run like many iterations to make sure that we are running the final code, the most efficient code. We also want to take good results of all the numbers of all the execution times and so on. So rather than writing all this by ourselves, there's a great framework in Java for doing this, which is called
JMH.
Yep, JMH. So of course I'm using JMH for this. It helps you write benchmarks, even for microcode, micro benchmarks like benchmarking a given method, or for kind of black box performance. It's also doable. So just for curiosity, how many of you use JMH? Okay, I would definitely recommend you to check it out, JMH. It's also very, very good for even setting up regression testing on your code. It's pretty cool. So I'm using here JMH. I don't know, especially people in the back, you can read this very well. But this is very, very simple code. This is a little bit shameful. I do that all the time, I promise. I wasn't even caring here about checked exceptions. Don't do that. But it was just the purpose of benchmarking this. But don't do this in production. And this Java code is very, very, very simple. I'm using JMH. So this is the benchmark that I'm doing. And have a single method, which is called test. So the first thing that I do is I execute a query, have a helper method that establishes a connection. So I'm including the connection time in the execution cost, because that's part of the deal. I want to know what is the time of running a query, right? So I include the connection time there, and then over the result set, I iterate through all the records on the result set, and then I use a black hole. A black hole is part of the JMH, which is basically a sink. If I want to drop data, in this case I just want to read the data that comes from the database and forget about it. I don't want to do anything with it, just query, right? However, if I would just read the data per se, just calling the get method, get int or get string or whatever, the JVM may be able to optimize the code by realizing I'm not using it. And then optimize that, and then I would run faster than it should be. It's not exactly the case with the database, because data has been shipped over the wire anyway. But just in case, just to make sure, I use the black hole. Black hole, again, is part of the JMH and will take care of avoiding, of precluding the JVM to optimize away code that I'm not using. So if JMH, if you want to consume some data, just consume that over the black hole. So I get the int column, and then consume it, and then I read the text column, and then consume it, and then I read the JSON. JDBC driver does not support natively JSON, so I have to convert it myself. So I read the JSON column as a string, I do get string, and then I'm using here the JSON library from Google to parse the JSON. And then I consume it. So in other words, this code here, very, very simple. By the way, whenever I publish the slides, I'll tweet that. I'll also upload the code to GitHub. It's not yet done, but I'll do that tomorrow when I publish the slides. Okay, so you can test this at home if so you want. So this code is very simple. It does a query, select star from table, get all the data, and send it to the black hole, which means consume it. Without printing to the console, logging to anywhere, writing to any file. Just get the data. And this is exactly what I want to measure. What is the time to execute this query? So the data having 10 million records and waiting at 1.6 gigabyte, it is of course not a very large table. But anyway, it takes an average of 17 seconds to process this query. But it's not bad after all. I mean, it's reading 1.6 gigabytes of data and parsing it through Postgres and everything in the driver. So it's okay. This time is average over 20 runs. So we're pretty confident these numbers are.
Does it use TCP/IP?
Yes, it's using TCP/IP because I want to measure the whole overhead. The JDBC driver goes over TCP/IP, yes or yes. So yes, that is included. It is included here.
Are you doing that to local host or?
Yes. So that's a good question. This is running on local host. So I was trying to minimize the impact of the network, because if I would run over a given network, first of all, we know the overhead is going to be more, and then it depends on the speed of the network, and I want to isolate that factor, the speed of the network. Supposedly local host is very fast, networking-wise. Okay, so this query takes 17 seconds. But how long does it take for Postgres to actually execute the query? because that's a way of measuring the overhead, right? However, measuring always has this kind of problems, like the Heisenberg principle. In order to measure something, I need to interact with it. And if I interact with it, I'm changing its behavior, its performance. So it's a little bit difficult. In this case, this interaction is very heavy, because if I want to see how fast a query runs, I need to read the data from the query. And reading the data may involve a lot of work for me, so the performance I get, it's going to be difficult to measure again. So, again, back to my original question. How do I find out how much time is spent in Java, how much time is spent in Postgres?
We can count time between a send package to the Postgres and receive the response.
Sure.
Use the speed up or
That's one option. Now, it's a little bit tricky. First, because there's going to be many messages sent, and then we'll need to figure out whose responsibilities in each case. And then I'll probably need to modify the code of the driver, maybe create some dynamic proxies there to inspect that. It's a fun game, don't get me wrong.
You can use some sort of sampling profiler and figure out how much time is spent.
Okay,
probability.
shut up, I'll talk about that later. Of course, yes. But still, I want a precise measure about time spent. By the way, let's do an estimate. How many of you estimate that, so there's some overhead here, right? So if we can figure out the time it takes for Postgres to execute the query, the time to execute this Java program will be slightly bigger, right? Because there's some overhead there. So how big is this overhead? From 0 to 5%, raise hands. From 5 to 10%? From 10 to 20? Okay. 20 to 50? Okay. More than 50? More than 100? Okay, more than 100 would be it takes twice the time. Okay? All right. Well, I came up with this formula. Might be wrong, of course, but basically the total Java execution time, we may count that it's a Postgres query execution time, plus the network cost, plus the Java driver overhead, and our app processing overhead. What I did here is try to zero out some of these factors. The network cost, let's assume it's 0, because I'm running a local host, that was your question for. Let's suppose the bandwidth is infinite, and the TCP and Ethernet overhead here is small. It's not, but let's assume it's close to 0. So let's say this is 0. And Java app processing, come on, I'm discarding data. So let's assume this is also 0. So the Java execution time is going to be Postgres query execution plus the Java driver overhead. Now the good news is that I can directly measure from Postgres the time it takes to do the query. So no need to fancy stuff. And so there's an extension called pgstat statements that allows you to do this. Now look at these numbers. If you cannot read from the back, I'll read them. The total execution time was 17 seconds. The time it took for Postgres to execute the query was 8 seconds. This means a 120% overhead. Was some questions over there? No? Yep.
How? I mean, in MongoDB we have about 10% overhead for driver. 10%.
Okay. Don't get me started on MongoDB. No. MongoDB has done some really cool things, except for the database. But on the driver side, sorry. I said don't get me started on that. But the drivers are very smart. The drivers, first of all, understand the network topology. They know who the master is, eventually. They send over the wire exactly the same binary format that the database is expected to store the data. So there's no conversion involved. So I'm not surprised the driver overhead is small in MongoDB, but it's not in Postgres. So, well, this is surprising and bad news, right? Good news is that if you thought your Java program with Postgres performed well, it can do better, right? So if you thought Postgres with Java was fast, no, it can be faster. All right, so we're here. Now, the obvious question is, where the fuck is losing time, right? So let's try to find out. Let's try to find out. How do we find out? Let's run the query through the profiler. So, you know, we take Visual VM, the profiler, whatever kind of this bytecode instrumenting profiles, and we run the query, and we wait, and we wait, and we make ourselves a pizza, and we wait a little bit more, we watch a movie, and we wait, and then several hours later, try that, you get the results. And you know what? They are false. They are wrong. Why? The bytecode instrumented-based profilers in Java, they basically modify your code, inject bytecode dynamically, and basically in a, let's say, aspect-oriented fashion, they add some extra code to your methods. So there's a very, very significant overhead that, again, going back to the Heisenberg's principle, it changes what you're trying to look at. So I'll show you later how I came up with better conclusions about whose fault that here, and they had nothing to do with what I saw with these profilers. So basically they're lying to you and they take a whole lot of time. So they're not an option. So what else can we do? Well,
Perf has some plugin to the JMH.
okay, yes. So Linux perf is an option. In general terms, the solution to this is to use sampling profilers. It's also already hinted here while before. Sampling profilers operate in a different way. The way they operate is that at some interval of time, they take a stack dump, basically, of the running JVM. The good thing about the sampling profilers is that they do this in a way that is very lightweight. It doesn't modify the performance very significantly. I've seen between 0 and 5% in this case. I mean, 5% is already significant, but anyway, it's not taking hours, 17 minutes run, 16 seconds run. The bad news is that as long as they are sampling, they're not catching every code path possible. And indeed, depending on the frequency of the sampling period, you will catch more or less dumps, stack dumps, so you'll get more or less information. But the good thing is that being low overhead, they give us more or less an accurate view of what's going on. And we can use them to profile the code and look at the big picture. And we're gonna see the fat guys, you know, the people who's making us waste time at the driver's side. There are some of them. There are some specific for Java. I tried all of them for this talk. So I tried the lightweight Java profiler. I tried the honest profiler, the Oracle missing control. Now that, thank you Oracle, by the way, for hosting this meeting. And for allowing me to talk about Postgres. And that, correct me if I'm wrong, but I believe it's also a sampling profiler too, the mission control. I settled down on the lightweight Java profiler. It worked well for me. And it's probably very convenient for this. Linux perf, which was mentioned back there, it's a good option too. This is not non-Java specific, it is Linux specific. That's the same thing, at least conceptually. The good thing about Linux perf is that it gives us a complete overview, not only including Java, not including our application. It also samples on the JVM, the garbage collector, which is pretty cool. I mean, we can get those numbers also from Java too, but it's cool to have them on the same view. But it also inspects the I/O on the system, the kernel system calls. So it's pretty cool. The reason why I didn't use it is that, first of all, it is very complex to set up. You need to do a lot of stuff to get working with Java. You need to run an external agent to create some mapping symbols, debugging symbols, which will then be used for the parsing of the data. And the results that I got were definitely non-conclusive. They contain very little information about Java. A lot of information about the system, but few information about Java. And here I wanted to look at Java stuff more in detail. So I used a lightweight Java profiler. How can you use it? Well, I'm not gonna get into all the details here, but it's more or less simple. A lightweight Java profiler acts as a Java agent, so it's something you attach to the running JVM. You have to compile it, it's C code. So you can clone it. It's on GitHub right now. Most of the links now point to the old SVN repository, but there's a fork on GitHub. Then I modified some variables on the source code and then recompiled it again to basically increase the sampling frequency. I was trying to hit hard on my computer. The effective frequency, sampling frequency that I got is higher than the one that was intended here as part of the compiled code, but it was good enough. I got closer to, if I recall correctly, 4 millisecond snapshots, which is probably pretty cool. Sorry, 4 microseconds snapshots. So you can use it this way. It's not very hard. And then once you have built it, you have to launch your program with basically indicating the agent path that you want to use. This is a compiled code, and then also some sampling profilers require this extra option, which is only available on Java 1.8 version 60 and over. It's called preserve frame pointer. If you don't use this option, you'll get less data, or you'll get more thread dumps, stack dumps, that you will not be able to identify the methods. Once you've done this, you run this and you run your Java program. This program will output a file called traces.txt, and this is a text file you can inspect, you can look at it, and it contains the thread dumps and grouped by count. So basically, you got this many number of stack dumps, this stack, and gives you the full stack. So you can basically inspect how many times a given code path has been run throughout the sampling period. Sometimes you may need to clean it, and there you have the information. Now, how do you look at it? Have you seen the fire? Let's burn this in flames. There's basically a really cool project called Flame Graphs. It's developed by people at Netflix. And they do some coding apart from watching movies. And they built this really cool software that basically takes stack dumps, right, and turns them into beautiful pictures. Which is, after all, after this so many text slides, we want to see some graphs, right? So it's really cool. You just clone this repo and run this script. So first of all, you use some awk script to basically group the stacks. And then you run through a Perl script that generates a SVG file, which you can interactively explore. So let's not wait anymore. How does it look like? Well, remember that we are trying to infer what is the overhead. So rather than looking at there's many factors that contribute to that overhead that I showed you before. So the first goal of trying to analyze this overhead is to go smaller steps. So let's start with a simpler example, because otherwise it's going to be a little bit messy. So this simple example is I'm just going to select the integer column. So the query is select I from number, and then I consume through the black hole this number. That's it. No strings, no JSON, no nothing, just the integer. The overhead, it's still, at least to me, surprisingly high too, at almost 7% overhead. I mean, I'm just getting an integer from the database. and have almost infinite bandwidth. So, can you make any guess who's the, because my code is one line of code.
It's a task switch, I guess.
I cannot measure task switching because I'm just using the Java performance. If I would use Linux perf, I could measure that. But at least there's some, might be, but at least I know of some other overhead, which is fixable. I can fix it in my single line of code. So who's in this line of code making some overhead?
Field name, black hole.
No?
Get value with index.
Yes, get value with index. So let's look at the graph. We'll find out by looking at the graph. So here's what it looks like. This is a flame graph. Yeah, well, it's easier to understand than it looks like. Let me explain you a little bit. I'm gonna show you this is non-interactive. Let me switch to the interactive version. I'm gonna sit a little bit here, if you don't mind, or try to. So let's open this graph, because it would be easier for you to spot. So this is gonna be query 1, SPG. All right, so this is cool because this is interactive. I can, well, I don't know if you're going to be able to read, especially from behind, but I'll try to explain. So basically, this kind of graphs, first thing that they do is the width represents the execution time. So this long bar here, which if I just highlight it, says that it's 50% of the time. So this method, which is receive tuple version 3, so it looks like a Postgres driver method, it's taking 50% of the time, the execution time. The other one over there, for instance, which is array list add, right? It's taking 4.7% of the execution time. If I want to look exactly at the total time, I just need to read over the top. So the total time is comprised of this small method, this one, the rest of the received tuple, this one, this one, this one. So you basically, if you paint what is on top of all of them, you get the whole execution time. Now, this is something you don't need to look at to identify the problems. By the way, these stacks are not perfect when run through JMH. So some nodes which should be the same one, so this receive tuple version 3, it's also going to be happening here and I think here. Let me hover over that. Not this one, but this one, yeah. So this bar and this bar are the same. They're not aligned because JMH, it's also generates some code dynamically. Introduce one extra code path over there. It's not a big deal, and we could manually write a better awk script when we group them to fix this. But anyway, it's not a big deal. So basically, if we look at this picture, we see that receive tuple version 3, which accounts for 50% of the time, plus this one, which accounts for 12% of the time. So receive tuple version 3, it's accounting for 62% of the time. If we look a little bit further, and we look here at the process results, or even query execution, here it takes 62% of the time, which adding to this, execute query another 15, so we're almost approaching 80% of the time. So 80% of the time is receiving the data from the database. Okay, so that's part of the deal, right? We're talking with the database, that's probably the time it takes also Postgres to execute the query. So again, where's the overhead? What about this guy? Hash map. What is a hash map doing here? It's taking like 13% of the time. Hash map? Hash maps are fast, right? No, they're not. Let's go below the stack and it says get. So it's a get method from a hash map, taking the same time. And then it's find column index, which is being called by find column, which is called by get int. Oh, so get int, if we go back to the code, there's a get int, and I use the getInt, which receives a string as an argument, which is a column name. There's another method which receives an integer, which is the position of the column in the result set. It looks like, and we haven't done this, we needed to check even the source code, but it looks like that getInt, it's gonna call the getInt by position, and it's gonna find the position calling this method called getInt is calling find column. Find column, it's calling find column index. And find column index, I'm pretty sure, have a look at the source code, well I did, but anyway, that it's using a hash map. Well, it makes sense, right? So I have result set has column names, and then a number is a position, and then I just do a get. Well, this hash map, which is very small, in this case contains 3 entries. No, indeed 1 entry, in this case, is eating 13% of my time. Whew. So, first things, how can I optimize this code? Well, rather than calling getInt column name, let's say getInt of 1, indexes in SQL start by 1, ABC, and I'll get rid of this. Second, don't forget this. Hash maps, if you call them many times, they are very slow. Why they are slow? Any idea?
Calculate hash.
Well, the hash, it's depending on the implementation, especially if you have overridden it. But string hash is not the most expensive operation. Default one. Any other idea? It's not captured here because of the sampling period. But now that I've done this, now I can use the real profiler and I can try to profile the hash map, right? And I will get the results very easily in this case. You have an idea?
Maybe creating objects, creating keys, values.
But it does that when it, so this hash map contains the mapping from column name to column position. So in this case, it's 1 entry. Column I, position 1. That's it. What?
Enumerate.
No. Okay. What it takes time here, it's equals. What? Equals takes a lot of time because when you're comparing references and the object is the same, it is very fast. But when it's not the same object, it's iterating the string. Even if the string is small, we're executing this like 10 million times. So it all adds up. And this is, by the way, one problem that we found in ToraDB. We discovered this when programming our database. We were spending a huge amount of time on equals. Solution is to, of course, intern or pool as we end up doing the strings that are common. Okay, so we found this overhead here. The rest of it, this is basically it. There's some extra overhead over here, which is, again, the hash map. It's still the same thing. And yeah, pretty much it. So the non-driver stuff is basically this, hash map and hash map. So getting finding the column. So finding the column is taking here over like 15% of the time. This looks like 15% of my code time. This is not precise, and I've found some small discrepancies between the time reported by Postgres and the time reported by Java. But it gives us a really good overview of what it's slowing us down. Good enough. Let's get back to the slides.
So, is it possible to, for example, to cache it using some caching on JDBC level, or things like that? Instead of find something in the map or using it?
Yes, you could do that, but it's not easy to cache that without using a hash map for the caching. Right? But of course, there's some ways of doing it. And by the way, this find column is a 15-line method. So I mean, you can send a pull request to the JDBC driver. Might do that too. Okay, so let's look at more examples. Let's move on a little bit. Let's look at the column, the text column. So this code is mostly the same. Now I'm just going to read the text column and discard it, right? What is the overhead? In this case, the overhead is 72%. A query that in Postgres took 3.5 seconds, Java program took 6 seconds to execute, almost twice. So where's the overhead here? Well, the first one we already know, finding column, but there might be something else. What is it?
String copy, extra garbage.
It's not exactly string copy, but it's basically managing the strings. So let's look at that. Let's open this query too. By the way, let's close this one. So this is how it looks like with the string. We can identify here the map stuff. No, this is not the map stuff. It's going to be here. Yes.
Is it possible to increase your fonts?
Oh, if it's, yes, I'm pretty sure it's also my fault. But haven't been able to determine that. No, I mean.
No, Control plus.
Oh, yeah. Problem is that I won't be able to.
Thank you very much.
Okay. Oh, well, we can see the bottom part. Oh, okay, good. So there should be some overhead here related to finding the column, but I don't see it right now. Oh yeah, and I know why is that. So I'm trying to find the hash map. Here it is. It's now smaller in terms of proportions because the overhead is higher, right? So it's a smaller bar. So this one, this stack here, it is the finding the column as a string. What happened before with the integer. This is getting the data, receive tuple version 3. So this is just getting the data. You see that there's more stack here than we had before. This is because this program was running for longer periods of time, which capture more samples, which means that we get more data, probably. So this is part of the execution process. So no, it's not overhead, and I believe these two stacks to the left are, this one is related to network 2, and this one not. So this stack and this stack, which should be the same one, so this one and this one is a string overhead. This is what accounted for that 70% overhead. And what is the problem here? We are decoding UTF-8 from an array of bytes. That's it. Of course, there's more than this, because then there's garbage collection, because we're doing a lot of object creation here, and then discarding them. So yeah, managing strings.
Any chance you tried this on Java 9 with compact strings?
No, but that was a really cool idea. But I didn't try that yet. Yeah, they will take a less amount of space. In this case, the strings are ASCII strings, so they will take 1 byte versus 2.
And no decoding.
I'm not that sure about that part, because I believe the driver, it's performing the decode itself. Well, it's calling an internal method for the decoding, which is called decode. This might not use time on Java 9 with compact strings, but I'm sure this one, which also amounts for a significant amount of time there, this plateau over here, is doing something with the code. So I'm not sure it will completely eliminate the problem. And this is a real shame, because my program is using UTF-8, the Java, right? The server side is UTF-8, but I'm doing conversion to bytes. So Postgres is converting from UTF-8 to bytes, then I'm parsing from bytes to UTF back again in Java. And this means a lot of time. If we add the JSON fields, that's where we get the 120%. And Who accounts for this? Well, it's not hard to guess. A little bit because of the finding the columns, a little bit more because of decoding the strings to UTF-8, and a little bit more to JSON. So if we look at this one, so if we look at this one, we can very easily see how JSON accounts for all these, which is 43% of the time. So 43% of the time, I'm just parsing the JSON. Why? Because Postgres sends JSON as text over the wire. So not only Postgres is spending time of converting from its internal binary efficient representation to text, but Java, it's parsing this from text to probably internal binary in-memory representation. Doesn't sound like a little bit stupid? Okay, so this is how I find out about these performance problems, what the overhead is, and where it comes from, just by using this tool and looking at these beautiful flames. Finally, well, I already mentioned this. What if we just use fixed column positions and call getInt of 0 and 1? I thought they were starting on 1. I'm not sure. They might start on 0, doesn't matter. The thing is that I'm not using the hash map here. Look at the overhead. Now the overhead is 3%. It was 6.7 with a single column, so with 2 columns could be significantly higher. Should be more, because I'm decoding a string here. But some runs, you know, there's some variation. So it should be higher than this. But anyway, we clearly reduce the overhead. This is how it looks like, the stack. So, some conclusions, because I think running a little bit late, but I also have some more stuff for you. So, first of all, I found it very convenient to identify these hotspots using these flame graphs. This all started as part of our ToraDB work, where we also, of course, want to make our database efficient. And by using the typical profilers, the results that we were getting were absolutely misleading. We were seeing some hotspots, and then we were trying to fix them, and then performance didn't improve, and until we really discovered that they were lying to us, and they were very slow, and they were not very reproducible. Then we started using this, and by looking at the flame graphs, the same way Netflix is doing, we were able to identify more precisely where the hotspots are. The numbers are not exact, they're not precise. There's some differences, but at least you see the relative spending on time, and that helps you a lot. Now, once you have done the sampling and then generate the flame graphs, what you can do is use the typical profiler to profile the method, the hotspot that you have identified. That will incur in less overhead for this profiler. You'll get more accurate results, and you'll get full stack traces, which is something that you don't get with the sampling profiler. We also thought about like taking the fastest processor available on Earth right now, because that will be able to sample with the highest frequency, because it's CPU bound. We haven't done that yet. Also mentioned this, the string pooling, and of course, if you go over a LAN, these results will be even worse. So if someone says that Postgres is slow, ask them about their drivers, because probably the database is very fast. Just install the pgstat statements extension and look at the numbers. You'll see whether the database is really slow or not. What else? I want to introduce you to another project that we are working on our company, which is open source too, not released yet though. And it's just very, very early stages. But we want to call it PGJ. What is PGJ? The idea behind PGJ is to try to avoid all this overhead. How do you avoid this overhead? Well, you have to avoid two things. One is the network, the other one is all these conversions. How we can do that? There's one very cool feature in Postgres called background workers. Postgres has an architecture that is process-based, Everything is process, not threads, processes. And like when you do a connection to Postgres, Postgres will fork a process, and that process will take care of your connection. Well, Postgres is also its own internal maintenance processes. And there's a third type of processes that Postgres, sorry for the cacophony, can have, which are called background workers. And that is a process that you can launch that Postgres will take care of it for you. So it will manage, Postgres will manage the life cycle of this process for you. And what can you do in that process? Anything. You can even access the Postgres shared memory. The way internally Postgres works, it's via shared memory, a large segment of shared memory. And it, of course, coordinates the areas of memory which their sub-processes can access. But all the data I/O happens through this shared memory. So if I could launch a worker process, this is background workers, then I could access this shared memory, and then I could do two things. First of all, completely avoid the network. And second, I would avoid also copying, because I will be directly accessing the data. I will have the data there. I will avoid this like string conversion that we've seen, it's so painful. Now, the problem is that Postgres is written in C. So, how do we do this? Well, what we have done is create a background worker, because you can do that in Postgres. You extend the background worker API and you create background worker. Within the background worker, we'll launch a JVM. And Postgres, in order to access this shared memory, has an API, C API, called SPI, Server Procedure Interface. So we are wrapping this SPI through GNA to make calls to it from Java. So with all this infrastructure, which seems like a big deal, and it was, we are able to run Java programs inside Postgres. They completely avoid network transfer, and they avoid, for the most part, or will avoid the coding and encoding of data, marshalling and marshalling. So this is it. It's not published, it's not done. It's still a lot of work left to be done. But if you like the idea, again, feel free to ping me. You're very welcome to join this code, which will be, of course, open source. And last but not least, I'm finished with performance. But I also wanted to give you a small hint about what else I'm missing from the drivers. Cool functionality that Postgres has that is not exposed via the drivers. And I would like to see that as part of drivers or any solution to run Java code with Postgres. Most of them I have already mentioned. The first one is to have JSON to be shipped over the wire as a binary format. This is very straightforward, and as I mentioned before, JSON is sent over the wire as text. So there's a double conversion from Postgres internal binary to text, and then from text to whatever you want to do in Java, which it's going to be parsing again. It's a real shame to have something parsed and have to parse it again. And you've seen the performance. It's terrible. So I'm advocating for doing this. It involves changing the Postgres protocol, which is like a hard API, so it's not easy stuff, but it could be done. Also, Postgres protocol is quite extensible, so it could be done. It's just there has to be an agreement on the format, the binary format. Text format's very clear. The binary format's not that much. There's been proposed some serialization formats, which could be good for JSON, and there's no decision. There's no move forward this. But it's there. Also, some custom formats or some complex formats are neither sent in binary format over the wire. They're also sent as text. Like if you try to come up with something fancy in Postgres, allows you to do like many fancy type of data types, it will come out as text over the wire. Again, that's a real shame. I would like to be able to say, hey, this is my serialization format. I want to plug this into Postgres and then serialize this however I want, and then I'll extend also the driver to parse it accordingly, and then I'll ship everything in binary format as I want. That would be really cool, but that's a huge amount of work. Also mentioned logical decoding, which allows you to extract differential changes from the data that is changing Postgres. There's no support for the drivers who are doing this. The only way of doing it as of today is by wrapping the C library libpq with GNI. There's no support in the drivers for async queries, for like setting up a pipeline. I mentioned that before, so you can fire like 5 queries at once. They will execute in the same order, but I will not have to wait for the results for every query to launch the next one. And then if some of those queries fail, it's on me, right? But at least I would like to have that possibility. There's also no support for Unix domain sockets in the Java driver. However, this is the easiest one to accomplish. Most of the infrastructure is already there in the driver. So if you'd like to do that, you can work on that on the JDBC driver, or you can also work that on Phoebe, which is also prepared for that. And also limited multi-server support. Right now the drivers are single server centric. And I would like the drivers to understand that the reality is that nowadays Postgres is run as a cluster with replication, with many different nodes, and you may target them in a different manner. So, how to fix this? Well, everything that I've been talking about today, absolutely everything is open source. So, you know, fork and PR. Fork and PR. Feel free to contribute. You're very, very welcome in any of the projects that I have mentioned today. You're also welcome to join the Phoebe project, which needs some love lately. So you can work on that. If you want to work in a small code base, that is a cool new driver for Postgres. If you want to work or learn about reactive Java and Postgres protocol, this is your place to be. And also this PGJ project that I also mentioned at the end of the talk. This is a really cool thing to run very efficient Java code, like inside Postgres, to run queries significantly faster, and also access all the functionality that is not exposed via the drivers. If you want to work on this, just let me know. We'll be happy to talk. So basically, that's it. If you have more questions, I'm very happy to answer them.
Okay, so. Okay, guys, it's time for questions and answers. If you want to ask a question, please wait for microphone.
Sure. Well, thanks a lot for the talk. I have 2 questions related to performance. First question is about official JDBC driver. What is the additional overhead when you use the driver inside the highly concurrent application?
Mm-hmm. Okay, so that's a very interesting question. How do you handle concurrency within the official driver? The way Postgres works, I mentioned that before, is that it creates a process per connection. So, and that process is a single unit of concurrency in terms of Postgres. It's a process. So it cannot run that process more than one query concurrently. So if you can use threading in the Java driver, that's allowed because it's Java. However, calls that go to the database will be serialized. Because at the end of the wire, you only have a single process listening to you. So you could use threads if you need to do parallel tasks and only one of them doing queries to the database. Otherwise, as I said, they will be serialized. The driver per se is thread safe, but the calls to the database will be serialized. If you want to do many things in parallel, you will need more than one connection.
Right.
That is supported, and if you're using a connection pooling or something, which you should, by the way, Hickory connection pooler is my favorite one, then you will be able to execute several queries in parallel.
Well, but when my application opens a lot of connections, is there any additional driver overheads?
Not for opening a lot of connections per the driver, but definitely Postgres will start to suffer if the number of connections is very high. It usually performs better with a smaller number of connections than a higher, well, mostly any database. The connections means 2 things. First of all, some overhead on the connection side, but mostly if you're having like 1,000 connections, it means you may have like 1,000 queries running at once. And databases are not that good at running 1,000 queries in parallel. But if you use a good connection pooler between your application and your database, especially on the Postgres side, like PG Bouncer, then you will be able to work with that paradigm.
Which brings us to my second question.
Okay.
Actually, well, second question is about connection pooling. What is more preferable to use one of the Java libraries for connection pooling, or to use PG Bouncer?
Okay. So who thinks the best answer is Postgres connection pooling? Okay. Who thinks the best answer is Java connection pooling? What the rest of you think? Okay, so the rest of you got the right answer, both. The best thing, the connection poolers actually add very, very little overhead. So the best thing is to have one pool close to the database, co-located with the database in the same machine as the database, protecting the database from developers abusing the database, which happens a lot. Basically, if you're running on Amazon or whatever, it's so easy to create new machines. Automatically, they will create connections, and the database will die at some point. So have one connection pooler in front of the database, co-located with the database, and have one on your side to cache the connections. And then the poolers will talk to themselves very, very well. It's very little latency overhead.
Thank you.
Next question.
Thank you very much for your speaking. I have one question. You are sorry.
It's okay.
One question. You were speaking that you use JSON as a type of date. What about protobuf?
So I mentioned that I would like to have some serialization format over the wire for JSON.
Yeah.
So there was some recent discussion about precisely supporting protobuf in the Postgres protocol. The answer was it will most likely not be implemented in Postgres because it involves a change in the protocol. However, for JSON itself, so the idea was in general to support protocol buffers as a serialization format for any query, not necessarily JSON. For JSON, I don't think it's the best option because protobuf means has the notion of schema, and the idea of a JSON is that you can have whatever you want. So either you create dynamically all the schemas, which is doable but involves some overhead, or you cannot. So when looking at serialization formats for JSON over the wire, we basically looked at some forms of binary JSON, which are basically, there's one called universal JSON, UBJSON, if I recall correctly. And there's CBOR, which is a binary representation of a nested hierarchy of key values, and a couple more. If you Google for that, for binary serialization format for JSON, and probably my name because I sent some mails to the Hacker mailing list, you'll find the suggestions that I don't remember all of them right now.
Thank you very much.
Okay, any more questions? Come on.
You can ask in Russian too if you want to.
Any volunteers? No.
Over there.
Okay.
I think I asked this before. Is that working? About Java 9 again. So have you done any experiments so far with Java 9? So it seems like there's a number of places where your performance can boost with 9.
Yeah, I completely agree. Unfortunately, time is very limited. And no, we haven't. We haven't done any testing with Java 9. But I was definitely looking at the compact strings option, which we were mentioning before, which basically allows in Java that for most of the encodings that can be represented with 1 byte, rather than using 2 bytes per character, you'll get 1 byte per character in Java 9 with this option. So that would definitely have a significant impact on performance and garbage collection, and also on decoding and encoding of strings, which might not be necessary under these encodings. So I'm pretty sure that will solve probably most of the string parsing overhead that we saw on those flame graphs. Not all of it, but probably most of it. So it would be a nice addition. As soon as I'll publish the source code to the GitHub repo, hopefully tomorrow, I'll invite you to do a pull request.
I also wanted to mention another talk done recently by Nitsan Vakar, where it goes back to your slides where you mentioned that decoding perf can be hard because you need to create special mapping from JVM generate methods into, because otherwise perf will just give you a bunch of addresses without any demangling. So there are a couple of projects running on GitHub, and pulling those together, it allows you to basically generate perf stats with the old methods demangled. And in order to explain how to do that, there is a YouTube recording with Nitsan explaining exactly, the names of the projects and how to do that.
Cool. That sounds really cool. I would like you to send it to me later, because I may include it in the talk. Thank you. Yeah, that sounds very interesting.
More questions? Okay, thank you, Alvaro.
Okay.